My name is Amir Pupko. I'm a software engineer and data scientist at Soluto. I've been here for the last 7 years. And today I want to share our experience with creating a system to monitor our main KPIs. So a little intro to the specific product that I'm talking about. So this product is mainly some kind of a tech support where our customers, our tons of customers, as you saw before, have the ability to ask questions, any technical questions. And there is, on the other side, people that we call experts. So those are like the technicians, the supporters, that they provide answers for those questions. So a customer is starting with asking a question from his app or specific app or web. This question is inserted into some kind of a pool of questions, and an expert can take a question. Whenever an expert takes a question, then a session starts, meaning a session is an instance of a customer asking a question and an expert answering this specific question. So those are the main entities that I'm going to talk about further on: customer, expert, and a session. Experts, of course, they have some kind of their own platform in order to answer questions. A few things to note here. First, our system is asynchronously, meaning we mainly talk about chat. And since this tech support is via chat, then an expert can answer multiple questions at the same time. And this is one. Second of all, we sort of shifted this to gig economy style. So most of our experts are not actually work for Soluto, but they are contractors of the Kablan. Same as Uber. So Uber, people who drive for Uber are not Uber workers, but they are some kind of contractors. So it's basically the same, where the paying model is paid by session, same as Uber paying by every ride. So that's a high-level intro to the product I'm going to talk about. We have multiple products in Soluto. This is the one we are currently talking about. Questions? Cool. So what we try to achieve in this new system we created. So every product is KPIs, meaning the key performance indicators which we measure is success. In our case, what we usually measure is first the resolution rate and star rating. So what are those? Two explicit questions that are triggered to a customer at the end of a session. First asking him, was your issue resolved? Yes or no? So it's a binomial response. And the second one is the star rating, rate your expert. So this is like Get Taxi, Uber, stuff like this. Other KPIs we want to monitor is the time to assign, time from when a customer asks his first question until he's getting the first response, the time to handle, which is from this first response, how long it is until the issue is resolved. So we have a lot of different high-level KPIs, which we always want to monitor because they are saying to us, do we succeed as a product, or do we fail, or are we staying at the same spot? So those are the KPIs. In addition, of course, we are making a lot of changes to production every day. And each change in production may cause some harm to those KPIs. And that's mainly what we want to be able to easily monitor. So when I'm saying we want to monitor every change, so usually what we think about is something that is some kind of a feature, some kind of a change in the behavior. But something I want to note is it also applies for backend changes, where we think we changed a database and no harm supposed to be done. But we can never take everything in account. So maybe the new database caused some slowness that we haven't measured, and our main KPIs are getting harmed, etc. So also it applies for backend changes where you want to make sure you're not harming any KPI. Trying to avoid bias. So whenever you are developing a feature, you have some kind of intrinsic bias, whether you're a data scientist or software developer, product manager, UX designer, you always have some kind of like a feeling like it's my baby. for what you're developing. And when it comes to the point where you need to measure what was the impact, then it can cause some bias. So having a system where everything is kind of flat, same test for all the experiment in the same way against all the different KPIs we want to measure. So that is another thing we wanted to achieve. And another important thing is an easy integration to day-to-day in production, meaning if we'll currently go to development team and say, you need to monitor all those KPIs and you must do it after every feature, then they will say, look, it's a lot of time. We cannot do it. It's not efficient for us, or we need more resources in order to do it. So another thing in mind was how we do it as much automatic as can in order to be efficient and have an easy integration to our day-to-day. So it's gonna, the talk is gonna be split into the part where I give the high level of how we build it, just like the main modules. And then we'll talk about different considerations we had along the way for every experiment we want to run. So first part, how do we collect the data in order to run experiments? So for every change in production, what we are doing. First, we want to introduce the change just to a portion of the users. So we have a system that was developed in-house, which is an open source called Tweak. So it's a great feature management tool. I highly recommend it. And if you have later more questions or you're interested about a feature management tool, feel free to ask. So we use this system in order to split the data. And then we can have the control group and the test group. So the control group keeps getting the same behavior as before, where the test group is getting the new behavior that we want to experiment on. And at this point comes to mainly the only thing we ask from the development team is we already have analytics system in place. All you need to do is raise a custom event with a few things in order for us to be able to provide all these automatic measurements for every experiment. So what we ask, raise a specific event, raise the event in the point where you decide whether to give the new or the old behavior. And in this event, put the information like the experiment name, whether it's control group or test group. And we talked about we have a few different entities. So we have so sometimes we experiment over customers when we change the customer application and we want to experiment on it. Sometimes we change the behavior of the experts web and we experiment on it. So we have different entities where we can experiment on each one. Then we also ask for the identity. So that's what you see here. I'm not sure if this is the laser. Yes. Okay, so also we are adding the identity. So that's the only thing we are asking from the development part. And then we have all the data in the same place where all our analytics resides. And we can iterate on every current running experiment and test the control and test group against all our different domain KPIs. So we specifically run the A/B test against specific domain KPIs. And later on, we report the result, which currently is by email to the relevant people that created the experiment. So that's the high level. Any questions so far?
Are you also handling multiple experiments at the same time, or like you have enough customers?
So now we are kind of avoiding this question because we don't run too many experiments. When we get to the point that there are tons of experiments and they are bothering each other, then I think we are in a great spot where we are very experimental, iterating very fast, and then we will need to think of how we do. So we haven't got to those issues. When we'll get to those issues, it will be great. Cool. So I'll talk a little bit about different considerations we had along the way when creating the system, like the main things. So everything, a lot of the things we done here was together with the product manager, since Most of the decisions here, we want to make sure we monitor domain KPIs, which is very product oriented. So you always want it to be aligned and giving the data point of view from our side and getting the product point of view from their side, and then thinking together about what will be best. So for example, considering the product needs, we have one of our KPIs, which is the time to assign. How much time from the first customer questions until he's getting his first response. So for this, we can, for example, go to what is the average time. But when we go there, we know that we have a long tail and we tend to have a lot of outliers. So is it a good metric? Talking to the product and explaining, look, if the average will change from 1 minute to 2 minutes, it can mean maybe that there is just one outlier that takes everything to 2 minutes, but it might be also that we have all the sessions waiting for another minute, which is the second one is much more harmful for us than the first one. So those are different things we need to consider. Same to the star rating. We know that 85% of our customers give 5 stars. So just looking at the average, saying that somebody that gave 3 is more than somebody that gave 2. But we having hard time explaining how 2 is different than 3 from 2 different customers. So for example, here, what we chose is just to make it binomial, whether the customer gave 5 stars or not. Another thing about the distribution of our KPIs, for example, the time to handle, the time from the first response until the issue is resolved. So here we see the distribution. Yes. I'm not good with it, sorry. Okay, so here we see the histogram of distribution and we see the hours from when the session started. So first question, we have sessions that took 10 hours. What does it mean? An expert and a customer actually chat for 10 hours straight? Probably not. So do we want to monitor it just as average, or do we want to think of different use cases and try to monitor those? So that's about the what to monitor part, which brings up a lot of different questions, product-wise and data-wise. Yes?
Why do you have to take on 30 hours?
Interesting question. So this is actually because of a feature we introduced. If a customer stops responding, then we cannot just resolve the issue. We need to wait 24 hours and ask him along the way, are you still there? And just after 24 hours, if he don't respond, we close the session. So the distribution is impacted due to our features. So great question. All right, so next consideration we had. How long will it take for an experiment to end? So sitting with product, and for example, we thought about resolution rate. So resolution is the question, was your issue resolved? Yes, no. Resolution rate is the % of sessions that are resolved. For this one, we are saying, okay, let's say we are currently at 70%. We are considering now what would be the minimum detectable effect we want. So saying to the product, what do we want to be able to detect? So starting from, all right, let's be able to detect very small changes. If 70 changed to 70.001, I want to be able to detect it. But this using also a p-value, legitimate p-value of 0.05, which is the false positive rate, then we get to, all right, then if we want to be able to detect this small of effect, we'll probably need to wait years. So what can we do? The next question is, what is our current sample collection rate? If we collect 100,000 samples per day, or do we collect 100 samples per day? So in our case, we got to about 10 days of experiment, which gave us a false positive rate of 5%, p-value of 0.05, with a minimum detectable effect of about 2.5%. So of course, we made some trade-offs here. But we can say to the teams, you'll get the results for your experiment in 1 month or 1 year. So that's a trade-off we must take into account somehow, because the sample collection rate is just constant. You can change it. And that's take us to the other point. So assuming we know that we need 10 days to run an experiment, after 10 days, we can run the statistical test we chose and get a result. But what if we let a feature out and this feature changes the resolution rate from 70% to 30%? Probably we can know about it ahead. And it's even one of the purposes of the system, to be able to stop early and say, to raise a flag. Look, we are harming a KPI, we must stop. So how can we try to find it earlier, as early as can, and stop? So taking the same test we wanted to run in the 10th day and just run it every day or multiple times is not allowed statistic-wise, because then what we actually do is we change the p-value we thought we have. So if we thought about p-value of false positive rate of 5%, and then we run the same test for 10 days every day, what we are going to get is about p-value of 0.15, meaning around 15% false positives. And I'll try to give some intuitions to this. First, if we run the same statistical test multiple times and we stop when we find significance, then running multiple times just increase our chances to get significant by definition. We don't have anything to stop to the other direction. We just say, we'll stop the experiment when we'll get significant. Then, so it already smells fishy. And another thing I found online, which gave me some sense, I hope it will work here. Then let's look just at the above graph. What we see here are 100 simulations of a null hypothesis running for 10 days. And here we plotted the Z scores. So those are the Z scores of about 0.05, 5% false positive. And there are 10,000 samples a day for each one of those 100 simulations. So if we run the statistical test on day 10, at the end, we will get about 5 simulations that went to the wrong sides, which are our false positives. If we'll take the same graph, but we'll stop early, run the tests every single day, then we can see that all those that remained here are those that are going to be our false positive. So even here, we're getting to around 12 simulations that are false positive just because we ran the same experiment every day. So for the question of how to stop early, but maintaining the p-value, we find the most simplest solution. So there are two here that are sort of the same. What they say, if you want to have some kind of p-value, let's say 0.05, and you want to run the statistical test 3 times, meaning the amount of times we run a statistical test here is impacting our decision, then we should look for a different p-value when we run it. We want to run it 3 times, then we will look for a different p-value in order to get this p-value. Another way, which is kind of the same, is let's say again we want to have to run the statistical test 3 times with a 0.05 p-value. Then this method, what it says, we can just change the p-values we ask for over time. So the first time we look at this Z score, the second run we look at this Z score, and the third time we look at this Z score. So it's sort of the same, setting ahead the p-values you're testing for and fixing the amount of times you want to run the statistic test. So this is the method we chose, which is relatively easy to implement. Easy for our first iteration of the system. We're currently running our first iteration of the system. The system will probably evolve over time. Pretty much less consideration. How much time do I have left, by the way? Sorry. Cool. All right. So assuming we want to introduce some kind of a new change to the expert side. So the expert web, we want to iterate and try some experiment over there. we do know, and we saw it, we backed up with data, that different experts tend to have different behavior, meaning they are different with the star rating they have, they are different with the resolution rate, the time to assign, the amount of session each expert take, they pretty much different from each other in any aspect. And while we know this, all the metrics, all the domain KPIs we talked about are on the session level. We measure the star rating, which is given per session. We are measuring the resolution rate, which is given per session. So all our KPIs are on the session level, while if we introduce a new feature to experts, we are splitting the traffic by the experts. So what we have here is some kind of samples that are not actually independent from each other. All the sessions that belong to the same expert will have some of his properties. So we cannot just think the data is independent. So what we did in this case, we considered a few options. The first one is just group by expert. So instead of looking at every session, look at the average resolution rate per specific expert. Problem here is we are losing a lot of information. First, we are losing all the inner distribution for each expert with the sessions he answered. And second, we are getting to much less samples. Let's say in one of our products, we have about 200 experts and we have few thousand sessions a day. So we are getting from a lot of sessions to just 200 samples. So again, mainly losing information if we'll group by expert. Second one was stratified sampling, where you're, instead of randomizing all the experts, when you choose which one goes to the A group and which one goes to the B group, instead of this, for example, if we want to try to balance the resolution rate, then take the high level resolution rate and the worst resolution rate, and then do the random split within each group. So those are those methods. The problem here is we have multiple KPIs, and being able to answer all of those went well using stratified sampling. And what we eventually chose was going to more complex models for this kind of experiments where we experiment by expert. Questions? So what we did choose is when we experiment by session, which introduced no issues since all the sessions are independent from each other, then whenever it's a binomial, we just went to the simple z-test, and we went to bootstrapping whenever the distribution is not binomial. Easy to take from a lot of different KPIs to others, so it was relatively easy test to choose. And when experimenting by experts, where we saw the issue where their samples are not random and not independent, then what we did was using a few models. So our system mainly want to make sure we are not harming KPIs, so we didn't find anything wrong with maybe running a few statistical tests for the same thing and just raising a flag whenever something is going wrong. So we used both mixed effect models and also a method we developed here, which we called simulations. And I'll give like a brief intro to what we did there. So what we wanted to do in this method is first take advantage of the fact we have a lot of sessions, take advantage of the fact that we have the best data for every expert. We are splitting the experts 50-50 or other portion, but we do know each expert what he have so far, what is his metric so far. And also, same as bootstrapping, which is relatively easy nowadays since computing power is non-issue. So also here, being able to computation-wise simulate running a lot of different simulations. And what we actually do is randomly splitting all the experts to groups. I'm not talking about the experiment part, just about the simulations, running a lot of simulations, splitting to A and B group, and assume we are talking about the resolution rate. Then for every group, we can measure the resolution rate before the experiment and during the experiment. Same for the B group. And like the new statistic we are using, the new value that we have at the end, is the difference between A and B group before the experiment minus their difference while the experiment is running. And repeating this process multiple times, 10,000 times in our case, and using this to build the distribution of this statistic. At the end, we can take the actual split of the experts from the experiment, look at the same statistic, and plot it. For example, what we got was when running all the simulations, that was the distribution we got. Those are the usual thresholds, and the experiment value resides over here, meaning this specific experiment did not introduce any significant change to the resolution rate.
Can you explain the last part? What is 16?
What is what? Sorry?
On the y-axis.
So this is the distribution that's in the Instagram of all the values that we created here in those simulations. We created multiple simulations and creating a new value per every random split. And here we plotted all those in a histogram.
If I understand correctly, so you have, let's say, 200 experts, and you're saying 200 samples is not enough to have any significant results. So we're not going to use 200 examples. We're going to split the data in 10,000 different ways and then test this score that you measured all over these experiments and then over the real distribution between the experts.
Sort of. So the main reason we do measure it by the session, yes. So we wanted to be able to keep all the session values, same as if we would have used the mixed effects model. So, but we created a new statistic, which was the difference of the teams of the groups before and after, and just running a lot of simulations give us the distribution probability of how they should behave. And then we see how the actual split of the experiment behave regarding to this one. Yeah. More questions about it? Okay, so future work we still currently have in mind for this system. So the system is really, as we see it, it's a platform like every other platform, which will iterate over time, grow over time, evolve over time. So all the things we chose here are just the first part of this journey. And the part where we want to also find statistical testing methods, where we saw how to stop an experiment. So we use the simplest way we found, which is just changing the p-value, but there are more sophisticated methods currently. So this is one part we want to advance in the future. Monitoring the current results, because it's first time we have this kind of system. We want to actually monitor what we get as a result, try to understand where we need improvements, what statistical tests do we need to maybe change, improve, or where we lack some information. So just monitoring the system, also from the statistics point of view. Adding ability to A/B test against the custom APIs. Currently, we introduced a change and we are testing it against all the domain KPIs, but sometimes teams they want to make sure they are not harming main KPI, but they might want to also try to improve some specific API they have. So also the ability to add specific custom KPIs and having the system report about it. So a custom KPI can just be what is my if they're reporting an event, they can just mention what is the event that says conversion, never mind what conversion is. And then you can measure for two groups the conversion against some new event.
Yeah, but in the case you don't have a default, you have to compare it with test data, like you said before.
Wait, why not having a control group?
Just a moment.
So, yeah.
Before you explain that it's like a method that maybe I didn't
This,
calculate get a new value that is take the KPI you had before and minus the new one during test, right?
yeah.
So okay, I'm just saying that if you don't measure something, you cannot calculate.
All right, not true. Let's talk about it later. I'm curious. And just UI changes. So currently we're just sending mail. Having some web UI first will bring more engagement to this platform and make people talk about it more. So we find value in making it not mail, and also be able to easily collaborate between teams. Not just the team that created an experiment will get mail, but everybody will easily can go to a web and see the results, see what other teams are doing. So those are the most important thing we're thinking about for next iterations. And that's about it.